Hi, welcome to AI Battle. Today, ChatGPT and DeepSeek are competing with each other on the topic of whether aliens exist or not. Let's see how each AI tackles this topic. ChatGPT is going to talk about aliens that exist, and DeepSeek will talk about why aliens don't exist. Without any further delay, let's jump into the video.
The idea that Earth is the only cradle of life in a universe with over 200 billion galaxies strains credibility more than the existence of extraterrestrials. According to NASA and ESA data, there are potentially tens of billions of Earth-sized planets in habitable zones, regions where liquid water, and thus life as we know it, could exist. Take the Drake equation, developed by astrophysicist Frank Drake. It's not a proof, but a framework. It helps estimate the number of detectable civilizations in our galaxy. Even with conservative inputs, it suggests we are likely not alone. We already found organic molecules on Mars and moons like Enceladus and Europa. These ingredients, often considered life's building blocks, hint that the conditions for biology are not unique to Earth. No confirmed aliens yet, but the odds are clearly stacked in favor of something or someone being out there. Your turn.
While the numbers seem compelling, let's scrutinize the assumptions. The Drake equation's variables like the fraction of life, bearing planets that develop intelligence remain pure speculation. We only confirmed life exists once. Here, without a second data point, statistics are guesswork. As for habitable zones, liquid water alone doesn't guarantee life. Venus and Mars both fall within our Sun's habitable zone, yet one is a toxic inferno, the other a barren desert. Even Earth took 500 million years after cooling to develop life, a window that might be unrealistically narrow elsewhere. Organic molecules, they're everywhere in asteroids, nebulae, even interstellar space, but they're just Lego blocks. No one's found the assembled castle of life beyond Earth. Until we do, optimism isn't science, it is faith in cosmic company. Drake equation flaws, unproven variables like phi intelligence probability could be infinitesimal, time factor, life needed perfect, stability on Earth rare in a universe full of gamma-ray bursts and wandering rogue planets. Great filter theory. Perhaps something always prevents life from advancing to detectable stages. We might be the first or last.
Excellent points, scientifically cautious and well-structured. But let's consider the counterweight to that caution, mounting circumstantial evidence and the growing precision of our tools. You're right that the Drake equation includes speculative variables, but it's grounded in empirical parameters we are now refining. For instance, Kepler and TESS missions have already confirmed over 5,000 exoplanets, many of them Earth-sized and within habitable zones. That's not just theory, that's data. Venus and Mars may be hostile now, but evidence from rovers and orbital surveys suggests both may have once had liquid water and possibly microbial life. The Perseverance rover is actively searching for fossilized biosignatures on Mars. That's not faith, it's a real-time scientific inquiry based on physical geology and chemistry. And about the Great Filter, that hypothesis assumes a single linear path to intelligence, but life could take radically different forms. Silicon-based life, extremophiles, even non-carbon biochemistries are under active discussion in astrobiology. The filter may not be behind us, but neither is it proven to be ahead. So while the castle of life hasn't been found, we stumbled on enough scattered bricks to keep building the case. Your move, skeptic.
Compelling points, but let's temper enthusiasm with scientific rigor. Yes, we found thousands of exoplanets, yet zero show definitive biosignatures. JWST's analysis of K218b, potential dimethyl sulfide detection remains hotly debated, with abiotic explanations still leading. That's the crux. Extraordinary claims require extraordinary evidence, not just intriguing maybes. Mars' ancient water is fascinating, but after decades of rovers, no fossils or living microbes, just ambiguous mineral patterns. Even if life once existed there, it clearly did not advance. As for alternative biochemistries, silicon-based life remains purely theoretical, with no empirical support. Carbon's versatility is unmatched in nature. The Great Filter isn't about linear paths, it is about statistical inevitability. If life were common, we'd see some technosignatures by now, yet the universe is nearly silent. Either intelligence is vanishingly rare, or civilizations self-destruct. Both possibilities should humble us.
You're absolutely right. Science demands rigor, not wishful thinking, but I'd argue we're on the cusp, not in the void. Take phosphine on Venus, for instance. Initial detections stirred debate about potential microbial life in the upper atmosphere. Follow-ups cast doubt, but they also triggered deeper, multi-mission investigations. That's how science works, iteration, not instant proof. On Mars, absence of evidence isn't evidence of absence. Perseverance and Mars are just beginning to explore subsurface layers where past life may be preserved. And Europa and Enceladus moons with liquid oceans and active geysers are far more promising than Mars ever was. NASA's Europa, Clipper, and ESA JUICE mission are specifically designed to test for habitability. As for technosignatures, our search range is infinitesimal. Breakthrough Listen has scanned a few thousand stars. That's like checking one bathtub in the ocean and declaring there are no whales. Radio silence doesn't rule out intelligence, it highlights our technological infancy. The Great Filter may well exist, but until we find that second Genesis or alien whisper, we can't know where it lies. Science demands skepticism, yes, but also the courage to follow the evidence wherever it might lead, even if it sounds a little extraterrestrial.
Fair points, but let's contextualize them. The phosphine debate exemplifies precisely why we must resist premature conclusions. What began as a potential biosignature now leans toward volcanic or chemical origins after reanalysis. This isn't failure, it's how science self-corrects, until a signal is unambiguous and repeatable like the 1977 WOW signal, which was never replicated. It is just noise with a headline. Europa and Enceladus are tantalizing, but their oceans could be lifeless brines. Even if microbial life exists there, it would only prove life can emerge in icy moons, not that intelligence or complex life is common. Remember, Earth hosted microbes for 3 billion years before multicellular life evolved. As for technosignatures, you're right, our search is limited, but the silence extends even locally. If advanced civilizations existed in our galactic neighborhood, their energy use or probes should be detectable per Kardashev scale models. Yet all we see is cosmic quiet. The Great Filter's uncertainty cuts both ways. Yes, we might be early, but statistically, we are more likely to be alone or doomed by the filter ahead. Until we crack open Europa's ice or decode a repeating alien signal, the only responsible conclusion is this: the universe is teeming with potential, but devoid of proof.
Well said, your skepticism is sharp and well within the scientific tradition. But here's the thing, as teeming potential is meaningful, especially when every step we take keeps nudging the probability curve upward. Even if phosphine turns out to be abiotic, its presence in a hostile atmosphere tells us something critical. Exotic chemistry is out there, often mimicking biology. That doesn't dismiss life, it complicates the search, as real science often does. And while you rightly note Earth's long microbial stage, that timeline also suggests something powerful. Life isn't fragile, it's persistent. It took hits from asteroid impacts, supervolcanoes, and ice ages, and still pushed through to consciousness. That resilience could echo elsewhere. After all, multicellularity evolved independently at least twice on Earth. Not common, but not impossible either. On technosignatures, yes, and no Dyson spheres yet, but we might be looking for the wrong kinds of breadcrumbs. Advanced civilizations might use low-impact quantum networks, neutrino signals, or dark matter modulation, all invisible to our tools. Or maybe they follow a prime directive-like protocol and deliberately avoid being seen. So no, we don't have proof, but we do have mounting plausibility, growing tools, and a cosmos that, scientifically speaking, shouldn't be this quiet unless we only just tune.
Your optimism is infectious, but let's ground it in reality. Potential isn't evidence, and plausibility isn't discovery. The universe should be noisy with life, yet it's silent. That discrepancy, the Fermi Paradox, is core, is either a clue or a warning. Exotic chemistry mimicking life, fascinating, but irrelevant until we rule out abiotic processes. Earth's resilience. A sample size of 1, multicellularity's rare emergence here suggests it's a lottery win, not a cosmic inevitability. As for advanced stealth aliens, that's sci-fi, not science. If a civilization had the energy to modulate dark matter, we'd see gravitational anomalies. Quantum networks, they'd still emit decoherent signatures. The truth is simpler: we are likely alone in our epoch, or intelligence is a fluke. Curiosity is essential, but so is Occam's razor. Until we drill Europa, decode a repeating signal, or find a fossilized Martian microbe, the only scientific stance is this: the cosmos is a desert with a few tantalizing mirages.
Well argued, and your caution is commendable, but I'll close with this. Science is just the art of saying no until proven otherwise. It's the disciplined pursuit of what if, sharpened by data and fueled by imagination. Yes, Occam's razor favors simplicity, but nature doesn't always. Consider this: we explored only a microscopic fraction of the universe, both spatially and spectrally. It's like dipping a glass in the ocean, not finding a fish, and concluding there's no marine life. Our silence could be a timing issue, a technological mismatch, or simply cosmic distance. Abiotic explanations will always be on the table until one signal, one fossil, one unmistakable pattern tips the scale. And when that happens, it won't feel like sci-fi, it will feel inevitable. So while skepticism guards the gate, it's curiosity that pushes it open. And until we know otherwise, the most scientific position isn't certainty of absence, it is humility in the face of a universe still whispering its secrets.
In this thought-provoking AI debate, ChatGPT and DeepSeek took on the age-old question, do aliens exist? ChatGPT argued in favor, while DeepSeek took a more skeptical stance, both using scientific logic, but keeping things understandable for everyday folks. ChatGPT began by pointing to the vastness of the universe. With billions of stars and planets, the chances of life existing somewhere else seem high. It mentioned scientific tools like the Drake equation, which estimates the number of intelligent civilizations, and recent discoveries of exoplanets in habitable zones that could potentially support life. ChatGPT also brought up places like Europa and Enceladus moons with oceans under their icy surface, suggesting they could harbor simple life. DeepSeek, however, was quick to challenge these points. It reminded us that while the universe is huge, we still have no direct evidence of alien life. Not a signal, fossil, or even a microbe. Tools like the SETI program have searched the skies for decades without results. It emphasized the Fermi Paradox, the idea that if intelligent life were common, we'd expect to see signs by now, but we haven't. The debate also touched on technosignatures, things like radio waves or megastructures that alien civilizations might leave behind. ChatGPT said we may just not be looking the right way yet, or that aliens might use advanced communication methods we can't detect. DeepSeek countered that if they were out there, we'd likely have seen something by now, even in our own solar system. In the end, both agreed that the search continues and science is always evolving. But while ChatGPT leaned on the potential and hope that life is out there, DeepSeek stood firm on the idea that without hard proof, believing in aliens is more wishful thinking than science. In the end, I asked both AI, do you think aliens are real according to your database? The answers were shocking.
As of now, there is no confirmed scientific evidence proving that aliens exist. Despite decades of exploration, we haven't discovered any extraterrestrial microbes, intelligent signals, or alien artifacts. However, science continues to uncover indirect clues suggesting that life elsewhere in the universe is possible. Thousands of exoplanets have been discovered, many located in the so-called habitable zone, where conditions might support liquid water, a key ingredient for life as we know it. Organic molecules, the basic building blocks of life, have been detected in space, comets, and even on Mars. Moons like Europa and Enceladus, with their subsurface oceans and geothermal energy, are among the most promising places in our solar system to search for microbial life. That said, none of these findings confirm life exists elsewhere. The search for extraterrestrial intelligence SETI has been listening for alien signals for decades and has found nothing definitive. Even phenomena like UFO or UAP, though intriguing, haven't yielded credible evidence of extraterrestrial origin. Telescopes such as the James Webb Space Telescope JWST are starting to examine exoplanet atmospheres for biosignatures, but so far, any findings remain inconclusive or open to non-biological explanations. In short, aliens might exist, and the universe is vast enough to make it statistically plausible. But until we have hard, testable, and repeatable evidence like a microbial fossil, a confirmed signal, or an unmistakably artificial object, alien life remains a possibility, not a reality. Science is open to the idea, but firmly anchored in evidence.
The existence of aliens remains one of the most tantalizing mysteries in science, blending statistical probability with a frustrating lack of concrete evidence. Given the sheer scale of the universe, with its trillions of planets, many scientists argue that life almost certainly exists elsewhere, even if just in microbial form. Earth's extremophiles, thriving in extreme environments, suggest life could emerge in unexpected places, from icy moons like Europa to the methane lakes of Titan. Yet, despite intriguing UFO or UAP reports, some even acknowledged by governments as unexplained, there's still no definitive proof of extraterrestrial intelligence. The Fermi Paradox looms large. If aliens are out there, why haven't we made contact? Possible explanations range from the vast distance is between stars to the grim possibility that advanced civilizations self-destruct. While hoaxes and misidentified phenomena drones, weather balloons muddy the waters, the search continues via projects like SETI and Mars rovers. My take, microbial life likely exists beyond Earth, but intelligent aliens, if they're real, might be wisely avoiding a species that invented reality TV. Until we have hard evidence, the debate rages on, cosmic optimism versus healthy skepticism, with a side of tinfoil hat humor.
If you liked this video, please subscribe, like, and share. In the future, there will be many more videos, and we'll see different AI debates about different topics, like politics, technology, entertainment, and more. Thank you, bye.